Hi, I'm David. A few months ago, I put online a video about a wire animation made in the Houdini. And I had some requests to get some explanation on how I did it. So here we are, and I made this tutorial. So first of all, this is my first tutorial, so please don't blame me so much. Also, my microphone is a quite poor, very poor quality. Actually, it's an iPhone. And finally, please excuse my very bad French accent. That's it. So let's start. Okay, so here we are in Houdini. So let's go first with the geometry node. So the first thing to do is to make the geometry, the wire geometry itself. So let's call that base geo. Okay, so I have to mention that all the things I will show you now, they are not from me. I found that on a video on YouTube from the Houdini channel, and I will put the link in the description, obviously. And if you want a better explanation of what will go on this next code, you definitely have to check this video. So let's go. First of all, we need a geometry, something to check, to test. Let's go for the pig head, my best friend. This pig head, we'll have to maybe subdivide it, we'll make it more precise. So let's go for a subdivide node. Here we go. And from that, we need the normals. The normal should be on the point attribute. So let's go here for point. Okay, so let's put our first point to start the wire itself, wherever we want. That's not a big deal. We just put that one very low. Let's go for -5. It's not big. Oh, even 5. You will see, it's not a problem. Let's go for a first wrangle node. The best of the best. Here we go. I plug the point in the first input and the pig head on the second input. What I will do, I will just put the point on the geometry itself. So let's go for at P, so the position of the point will be the mean pose on the channel 1, and the position we are starting from is at P, obviously. And if I do that, poof, I should find my point just in here on the pig head. And let's put the pig head in here. We see we're coming just on this left here. It's perfect. I like that. Now we need a second wrangle node. This one. Okay, so first things first, there is a few parameters we'll have to tweak. So let's prepare them. The first one will be a vector. That will be the direction of the wiring. So let's call that D, and that will be a CHV, a channel vector. Let's call that direction. Here we go. The second parameter we have to tweak, it will be the amount of point we'll have in the wire itself. So let's call that NBR. I like NBR. It will be a channel integer, and this one I will call amount of points. Points shall be better that way. Okay. Next parameter we'll have to tweak is the gap between 2 points, the distance between 2 points. So let's call that step, and it's a float, obviously. So let's go for channel float. Let's go for step size. Next parameter we'll need, because we'll have to put some noise on it to avoid to come in a cycle and turn around the same position. So let's put a noise, but for that we need to be able to tweak the amount of noise we'll put inside. So it will get clear later on. Okay, so noise amount will be a THF again, so a float channel. Let's call that noise amount. And finally, we'll have to move along the direction. So same, we'll put something to tweak it. So let's go for float. I will call that up move, and that will be again a channel float and move. I think that's quietly what we need. So from that, let's make it nice. I will just put in there, that's the inputs. Okay. Now from that, there is a few variables that we'll need. So let's do it. The first one, okay. We'll make a loop to check point by point, or some kind of solver, but in a VEX code. For that, we need to get the starting point on each loop. So let's create a vector, call that current, and for the first step will be at t, for sure. Also, at the end, we'll have everything in primitive. So let's make the primitive right now. So an integer prim would be the add prim, and for the syntax, it's the gender and the string type. So the gender for sure is 0, and the primitive type would be a polyline. Here we go. So now we can start our loop. For, let's go for an integer, or call it I, why not? I would be, I should be less than MBR for sure, and we'll increase it 1 on each step. Let's go for the code itself. So the first thing we have to do, from the current point, we'll get the normal on the closest point of the geometry itself. So to get that, the closest point would be the near point. So we can use a near point, and so for that we need to put the geoender, that would be 1, because we are looking for the big head, and the position would be current, the current point we are looking at. So 1 and current. This will give us back the number of the point we are looking for. So from this point we need to get the normal. So we'll go for point to get the attribute we need. So we can see on the help we need the geometry handle, that will be 1. The string attribute name, so that's the normal, so it will be just simple n, and the point number is the near point. So let's go for 1. Here we are looking for n, and we are on the near point we found. And this for sure, we need to store it in the variable. So let's create a vector. I will call that ry. Why ry? Because it's some kind of referential I will create on each point of the curve, on the wire, and y will be the normal direction. It's okay, just a way to do it. What I will do also, normally it's supposed to be, but just to be sure, I will normalize this vector, because I've seen during some tests that sometimes the length of the vectors are slowly drifting. So okay, let's just make it clear, and to be sure we'll normalize it. So now we have our normal. Okay, I will give some room because I may come back later on that. I will create a second vector. This vector, let's call it RV, that will be some kind of tangent of the big head, okay, related to the direction we are following, and this will be simply a cross, the cross of the two vectors. So the cross from y for sure, and the direction we are following. Okay, so this will give us a vector that will be some kind of tangent perpendicular of the normal and the up direction. But first first of all, as I said before, I like to be sure, 100% sure that this will be normalized. So it's not big deal to put one more normalize. And by the way, I should put also on the dir in here, the direction vector, I should normalize it just to be sure that we have only normalized vector. Okay, so if I do that, I will get, it's not easy to explain, but okay, to show, I mean, I'll just explain later. Okay, in here, imagine we are on that point, we get a normal in here, and the cross vector, no, this one is not a good one, I will come back on that. Imagine we are on this point. The normal will be that way, and the up vector, let's imagine it's that way, going straight up. The z vector will go something like the tangent perpendicular of the direction. But if we want to add some noise, it would be very good to add at that point. So I will add it to the dir vector in here. To do that, I will just follow what I've seen on the video I put the link of. The curl noise is giving amazing results, so why making it complicated? Just keep that. So for the input, I will use the current vector and I will multiply by I. That will give some kind of very good randomness on this calculation. Okay, I think right now we should be quite good on that. Yeah, sorry, for sure, the noise, I have a fiber in here to control the amount of noise. I have here, so let's multiply this noise by the noise amount. Okay. A message. Oh, great. Let's remove the sound. I don't need some that right now. Okay. So now we have our normal vector, the up vector, the z vector, the tangent vector, I mean. So let's create a new point. So for that we need to create a vector new pt for new point. That should be simply equal at the current position plus the RZ here, RZ by the step size, okay, and I will add also the direction vector by the up move here. Let's see, and let's do that. From that, when we have all finished our calculation, we'll have to add points. So in integer a, let's call that a, never mind, it's just temporary variable, to be a add point on the, so the g handle will be the number 0, the geometry we are working on, the first input of the angle, and in here we will add the position of the new point, which is new pt. So we made a point, but we had if I just stop now, you will see that nothing is happening. Two reasons for that. The first one is that at the end of the loop, I have to tell Houdini that we finish with this point and now we move the current point to the new point, just to not make the same again and again and again. And in here we can see we have only one point because I forgot, I have to tweak this. Come on, seriously? 0.1, this will manage later, the direction is go for, let's say 1, it's perfect, and the number of points, let's go for 1000 right now. And okay, here we have only this, and we can see it's going. So what I can do is first move the up point, the up move. Let's make beautiful, wonderful. I like that. That's clearly not what we are looking for. If I go for the -1, it will be the same. It's awful. Clearly not what I want. I like it. No, I don't like it. So why that? Because okay, I add a new point that will go a little bit from the geometry itself, from the pig head, and further and further and further. So for that, what I have to do is to tell Houdini that you have to come back on the geometry itself. So for that, I will go for a new pose. Would be the first input, so the big head and the vector. We already know that. Up in here, we can see everything is coming in here. But here we have points. We don't have a polyline. Why that? Because we didn't have the vertex. So to add vertex, just put add vertex. And so we need the G angle will be 0. Prim num, the one we created in here, the prim, and the point num, the one we just had, A. So it would be 0, prim, A. Poof. And here we start to see something interesting. Yeah, that's what we are looking for. In here we can even change that. We can see, yeah, okay, it's not working so well right now, but yeah, we start to see something. So one thing we can see easily right now, we can see at the top, the starting point, everything is working well. We still have a big gap in between the lines when they are coming back. But in here, they start to get stuck on each other, and for sure we have multiple points in here that stay on the same place. If I increase strongly the amount of points, let's go for 10,000, we can see nothing is changing because we have 9,000 and something points stuck in the same position, same location all the time. So one thing that can be done here, I will use a dot product between the normal and the direction vector, because for sure if they are in the same way, I'm just going all the time at the same position, and the cross vector would be something completely crazy because it's the same vector. So to do so, shall be just after we got the normal. Let's go here. So if the dot product of so, by the way, if you don't know, a dot product will give you a number between -1 and 1. If the two vectors are exactly at the same direction, it will give you 1. If they are opposite, completely exactly opposite, that would give you -1. So, what I can do is doing the dot product. I will test the dot product between. So I said Ry and Gn. And if this one is higher than 0.95, let's say, we'll see later on, then what I will do, I will just reverse the direction. So, multiply equal -1. Here, we should see something different. We can see that the wire is going down. When the normal and the direction are very close, poof, is going upward. And if I had more points to do again and again and again and again, the point is that, yeah, the problem is that at one moment I will go on the same line continuously. What can be done for that? Here we have the noise. We can play with that noise. If I had some noise, yeah, they start to move and to come back on a different place. Yeah, this is it. This is what we are looking for. Also in here, as I normalize the vector directly in the vex code, I can go for crazy vectors I wish, and this is working too. Yeah, I think that's almost it. What can be done also to finalize the geometry is in here. We can add maybe resample node. Okay, and on this one, I don't know, maybe I will go from 0.1, but I don't want a straight one, I want a subdivision curve. And yeah, it starts to look something nice, I presume. After that, we can still tweak all the variables we have until we find something we really like. For sure, the noise will help to cover more of the surface. And that's, yeah, I presume it's not so bad. Let's go back to the straight one. yeah, that's it. I think that's the idea. Let's finalize that with the output node. So we are sure that every time we will refer to this base geo node, we'll come back on the final position of it. What next? Yeah, in here we have two variables that I think it's always good to store. Even if we don't use, but okay, it's not a big problem to store the Ry and the Rz will be as it will be the normal and the tangent of the point itself. It's, I think, good to store them. So for that, we'll use a set point attribute as it is here. Yeah. So for this one, let's see. So the geohandle will be 0. The string name will be depend what we put. The point number. Okay. So 0. The name will be let's go for n as it's normal. After the value will be Ry, and after I forgot what I have to put inside. Let me check the help of it. Okay, it's not this one. I have to put the point num first. That would be a Ry for the value, and yes, for sure, the mode in here will be set. This will give me the normal attribute. By the way, if you click on that, you can see you have the perfect normal as we are looking for, and just copy paste this one. I will store the tangent. I don't know if I can use that or not, but okay, never mind. That will be it. Tangent. That would be Rz. Okay, so I think now we're clear about that. So a lot of value we can tweak and do whatever we want for that. Let's reduce the recenter. Oh yeah, that's beautiful like that. Maybe increase the amount of points as 1000. It's not that much actually. Let's remove the normal. Let's see what. Oh yeah, I like this one. Yeah, it's great. If I reduce the noise, you see, we start to get something more straight lines, and yeah, I think that's it. So that was the first part of this tutorial, the way to prepare the base geo itself. Let's continue with the second part. Okay, so for the second part, what are we looking for? We are looking just first to create the destination file, all the way right. So let's go for base geo 1 for this name, and this one, base geo 1, it will be the starting point, and I will just duplicate that by keeping pressing the Alt key on my keyboard and just click and drag, and that will duplicate it. I have the base geo 2. Base geo 2, maybe I can can change the geometry. Let's go. What else can use? Yeah, the river toy. Wonderful. My two best friends, the river toy and the big head. Okay, I think I will flip that way. Never mind. After you can tweak whatever you want. You can, even if you wish, so you can change point location and go for maybe -5 in here. We start from the left side, and so as we start from the left side, I will go for 1 and 0 in here. And no, let's increase the moves in here. Maybe increase the noise. No, I did so bad. Let's go maybe on the z-axis. Just like that. Not so bad. Let's try if we can move on the. Yeah. Now it starts to look great, and maybe increase the up move. Decrease it maybe. Oh yeah, that's it. Oh yeah, baby. That's what I'm talking about. It's great like that. Okay, so now we have two geometry, the destination one and the starting point. So one thing we need to check is how many points we have on each. So this one, you can see, we have almost 20,000 points. That's okay, that's great. And this one, we have 15,000, that's okay, so I will use this one as starting point and this one to the final one. So for the simulation, let's go for a G node. I will not use a dot network as the volume swap is working quite well and there's no need to go for a complex dot network. So first thing first, let's import our two geometry with object merge. So I said we need Geo2 as a starting point. In here I will add a run alone because there's one thing I need is ID attribute. So I will just put in here run roll, let's say I add ID because my attribute is at integer and that will be equal at pt_num. Here we go. Okay, so from that I will need a volume close configuration. I don't have string, no, it's okay, we can use the close, and I will change that because I don't want a close but a string. That's perfect, and let's go for a volume solver. Here we are, that's it. So this solver, I don't want any gravity, so let's remove that, and if I hit play, for sure, nothing going to happen. By the way, my video card, it's my GPU is quite powerful one, it's RTX 280 with a lot of memory and everything. So right now I'm still using, if you look on the OpenCL, yeah, I'm still using the OpenCL for the solver itself. If your solver start to completely mess up and make crazy stuff, just remove the OpenCL. That will help you to keep it clean. Let's go back on the solver. I'm not going to use the collision right now. After it's up to you, you can do it. I won't. Okay, so now I will just duplicate these two nodes. So again, I select them, keep the Alt key pressed, and just click and drag. For this one, I will use the other geometry, which is Geo1. Here I still need my attribute, and I'll just move it, because I like to move it. And I will put that, I don't know, on the let's move it on the x-axis, and we'll go for -10, and it's just over there. It's okay. So let's go inside the volume solver, and as it's mentioned here, we can use pop force for to tweak, to get fun with the volume solver. So the first one I will have is first a pop wind. I used to do that because that gives me not the wind itself, because I don't care about the wind, I'm not using it, even the noise. I just want the air resistance, and that simple way to add it. Yeah, so just do it. From that also I will have the pop attract. So the pop attract of those who don't know what it's doing, it's just it's a force attracting all the points inside the solver to a specific location. So we can use the position, but we can also put points. And the points, I will just select something I forgot to do. Yeah, in here. Let's make it clear. Come on. I will go for a null, and in here I will call that target, whatever, it's not a problem. In here, so for the pop track, I will go in here and select the target. So in here, if we go for the average position, that means the center of the target geometry. It's not what we are looking for. We are looking for point per particle, and that's why we created before just obviously an ID attribute. And with that, okay, let's see what will happen. What will happen is that each point will go to the final location it has to go. So we can see everything start to move perfectly. That's perfect. Yeah. and maybe the simulation will be a little short. Let's go for 500 in here, and we can see, okay, all the points they are going to the to their relative place. But at the end, you see, one problem is that it will continuously move and move and move and move and move and move. They cannot stabilize at all because they are still moving all the time. So one way to solve that, okay, so we can solve or with a pop wrangle inside the solver itself, or with some pop wrangle and some wrangle in the geometry now. But okay, let's do all in the pop solver. So the volume solver. So pop wrangle. Let's put that wherever, we don't care. In here, what I have to do first, the input, the second input, I want the target geometry. So for that, I click on the target. So on the second input, I will go for a sort and select the target. In here, the code, very simple. We need to find the point corresponding to each point of our volume geometry. For that, we'll use a find attribute val. This, okay, so for this one, I will use the help file. Maybe the recording I'm doing, you cannot see the help file. To get the help, you just keep your cursor above the function you are looking for. You will see this, press F1 for more help. You just press F1 and that will give you a small window with everything you need to know about it. So the geometry, it's number one, it's the input one of the wrangle node, even if we cannot see it, but we configure it in the inputs. After that, we need the attribute class. So attribute class, we are looking for point attributes, because we can have point details or primitive attribute, but for us, it's just a point attribute. The attribute name we are looking for, it's ID. Then the value we are looking for is just at ID. At ID will be the ID of the first input of the wrangle, I mean the input 0. Here that will give us back an integer that will be the number of the point in the second input for the same ID. So this we will use to get the P attribute of it. So to get the P attribute, we need to use a point function. Again, I will press F1 to get it, and in here, the point we just need the geometry will be 1, then the attribute we are looking for, which is P, and finally will be the number of the point that the find attribute val. Okay, that will give us a vector called, I don't know, let's target P equal that, and if I don't do any mistake, yeah. This we can compare to our point to get the distance in between the point and its target. So let's do that. The distance will be, between at P and target P. And this I will use to set the speed limit of the point, because if I reduce the speed of a point, it will slow down and just slowly coast to the point it's supposed to go. So for that, I will use an attribute, float attribute, which is called, I think it's speed max. And I am not sure. How to be sure? It's very easy. I will go for pop speed limit. If I go on the pop speed limit, we can see that the maximum speed limit, I can set it, but okay, that's not the proper way to do it, because I need to make it dynamic compared to the position, to the distance remaining to go on the target. So I can, instead of this, if I click the cursor on that, you can see the pop-up showing that the parameter has speed max. If I create an attribute on the point that's named exactly speed max, that will act as the maximum speed of for the solver, I mean. So in here, speed max, let's check. Yeah, it's speed max. So if I hit play now, let's do one thing also to make it faster. Maybe before, so yeah, I can go for 10. Let's make it faster. We can see, okay, everything is moving well. And normally we should see it getting slow until it reaches its position. Because the closer so its position it will be, the slower it will go. Let's help to cause it very quietly. Yes, I like that. That's perfect. Perfect it is, I think. Oh, I like it. I'm proud of me. No, come on. Okay, so let's do one other thing. On the proper track in here, I will just reduce the distance. So I went to something like -10, I think. Yeah. So I will put 5 on the maximum distance of the proper track. That means only when the point they are less than 5 units from their target, they will get the force for the attract force. If they are further, they will not get anything. Let's test that. Normally, nothing should move. That's perfect. That gives me the opportunity to do one other thing. So let's do that. Let's create a curve. The curve in here. For the starting point, I will start from the origin. Let's go for 0, 0, 0. I will keep this one on the back, just to be sure I'm getting the correct target. And let's see if I had, so I will have a curve going there, then there. Let's enter. I don't want a polygon, I want a nerve. That will be much nicer, I presume. Okay, let's tweak it. Yeah, the final destination I will go for. Final point, sorry, -10, 0, 0, just to reach properly the target in here. And so I say 5, let's tweak the leader just to make it nice. In here, at this point I will just move it that way, maybe moving up, yeah. This one I will go, yeah, let's do that way. I know just have the null, just to have an easy way to find it, and I will call that curve, whatever, it's not problem. By the way, also, always put the reference you are looking for in iCaps when you are when you will be looking on it. That will go first. The iCaps are always going first in the search area of SOAP. So let's go for a pop curve force in here. I will put 2, but let's go for the first one. In here, you can see, yes, curve is getting first, because it's high cats. That's the point. In here, in Freedom, we have the curve first, that will attract all the points in that way. What we can do already is to tweak a little bit the global force, just to make it slow down at the end, because at the end we get the attraction from the proper track here, from the pig head, and that should be enough. Let's see now. Let's remove this. In here, if I press play, you will see, okay, all the points of the wire, they are following the curve, and yeah, the orbit form, then turn around and around and around. That is way too slow. So let's increase the force itself. The follow I will go for. It's 550. Let's see what will happen now. And maybe, no, it's okay, it's still working well. And we can see that in here, everything is going to the big head slowly. And it's not very attractive. Yes, it starts to be, we can see, oh, there's points again, and everything is going down. Yeah. No, let's do hide. Yeah, that's exactly what I'm looking for. Oh, that's great. It's working well. Happy recording that. If it's not, it looks stupid. Okay, no it isn't. Let's remove the guide if it's too much. Okay, and why am I saying that? I don't know. Yeah, it's okay, it's just sometimes to be refreshed. Let's put in real time. Yeah, okay, I like it. So, now what I'm going to do is in here, I will create a group by range, just to define a few points that I want to start the process of the section of the curve. So let's call that group start. It's not primitive, but point group. And okay, let's put 10 points every 15. Okay, let's go every 4,000. It should not give me so much points. Yeah, I like it. So this is start. In here, I will go the curve. I will use the group. So as I put the start group, only the points that are inside the group, they will get receive the force from the curve, the point curve. So if we do that, we can see only a few points. They are going there, and they will start to slowly pull the wire to put it back. For sure, as I put very less points, the force is very low. So let's increase the force in let's get crazy, 500, yeah. And here we can see just a few points. They are pulling the string. And okay, this is working well. But for the other point will be too slow. So what I will do, again, I keep press on Alt, I just slide it, and I will duplicate, check to remove the connection, and put in here. This one I'm not going to put the group, but on the global force, I will remove this part of the force. On this point, I will go for 0, move it a little bit in here. So if I show the guide of this one, we can see that it starts only here. Let's wait to close. Let's go maybe in here. So where it's black, there's no section at all, no force at all. Only from here it will start. If I press play now, just the first point from the start group, we get the section from the first pop curve. And then when they start to be inside the other point, they get it also in here. So in here I can see maybe the suction force need to be increased and that one. So the suction, let's go for let's try 50. It's just after easy to tweak it the way you like, and it's not a problem. And maybe I should go for some orbit force to make it, just to make it fun, to give more moves and everything. But we can see it's working. So let's go in here, the orbit scale. I will go for 25 maybe. We'll see what will happen. And let's go. What do we see now? Yeah, it start. And the orbit force is not doing that much. So I will reduce the suction. Let's go for 20, and this one I will go only for 50 because all the points they get the force from that. But here we are, and we can see, it start to move everywhere. It's creating some disturbance, and everything will go there until it's close enough to the big head and we get attracted to their final position with the speed limit again, making it slow. Yeah, okay, so it's working well. Maybe not last, but one more thing I'd like to do is that in here, the speed max, I would go for the square of this value. That means if it's higher than 1, it will get higher, and if it's lower than 1, it will slow down faster. If we go for that, we can also maybe put a little channel float to tweak ourselves the, I don't know how to call that, speed ratio. Yeah, and in here I can go maybe for 2, let's say crazy 5. Speed limit will be very high. I hope it's not too high. But when it will get close, it will slow down. Maybe also the air resistance will be too high, but okay, never mind. The idea here, we can do whatever we want. This is no big deal. Really, we do whatever we want. Yeah, that's working well. I think everything will go to its place. Okay, so the speed ratio is actually, I think, too high. Yeah, way too high. It's moving. One thing that can be done. Okay, so I will go for. I will just increase a little bit in 700. And what I will do? Let's remove the brain. The solver, let's go in there. I will just put a keyframe in here, and on the 600 frame, I will go for 0, put another keyframe. That means when you go from here to here, everything will slow down until this point, everything will be frozen, stuck in place. And let's do that. Here we go, and it starts. It's working perfectly. Yes, I get it. Don't stop. Keep going on. Yeah. It's a lot of points. Take care. That Houdini is doing well. It's a perfect match. This software is amazing. Really amazing. Okay, the speed is still very high, but it's okay. And no, as I get to this point, everything will start to slow and freeze. So, maybe it's a little too early, I will still have some wire not taking place. No, will be okay. Everything coming here, and you will see everything just slowly freeze in the correct place. Yeah, that's it. I think we get it. You can see at the end, everything is just in there. Yeah, it's perfect. After that, that's it for this month, I think. Yeah. Let me know if you feel like to get something for the rendering, but okay, you can export to Alembic file and render whatever software you like, or render directly to Houdini. It's no big deal to do. Okay, I hope you enjoyed this training, this small tutorial, a very simple one. And again, I insist, go check the link I send you. You will get a very good expansion of the guy did this geometry. That's amazing. And okay, that's it. See you later. Bye.